Unit 4, which is another fun unit. We're talking about changes that occur due to training. And for the next week and a half, most of this will be focusing on aerobic training. It's just that the name of the chapter is anaerobic training. So we're going to talk about endurance to start off. So here's our topic and outcomes. Just a couple definitions, reintroduce VO2 max, and just talk a little bit about how training can change that. So when it comes to aerobic versus anaerobic training, aerobics, also known as cardiorespiratory training, and ultimately what happens with aerobic training is you're strengthening your heart and your lungs. Okay, ultimately, or most of these changes that occur with aerobic training occur within the cardiovascular system. And as we go throughout this week, we're going to talk about a lot of cardiovascular changes, and there are some respiratory changes, but the changes are predominantly in the cardiovascular system. Conversely, there's anaerobic training. So this is going to help that with, like glycolysis, that kind of metabolism. And people that do anaerobic training are going to be better equipped to handle that short-term, explosive, high-intensity sort of exercise, right? So sprinting, lifting weights, that sort of thing. Although it's a little bit different with resistance training. But ultimately with anaerobic training, you're improving your muscular strength. So this leads us to endurance, which is probably more something you think about with aerobic training. So when we talk about muscular endurance, we're just talking about how well is a muscle able to resist fatigue. If we're talking about cardiorespiratory endurance, we're just how well is your body able to sustain exercise for long periods of time. Okay, so there's two types of endurance there. So this leads us into VO2 max, and VO2 max is something that we've talked about several times throughout the semester. But one way to look at VO2 max is that it's just the maximum aerobic capacity. In other words, it's a measure of the maximum amount of oxygen that your body can utilize. And this is a multifactorial measure, but it is heavily dependent on cardiac function, and specifically cardiac output. And we're going to talk about that later. So as we've discussed, and I think the next slide shows a figure with this, that as we increase our exercise intensity, unsurprisingly, oxygen consumption increases. But there comes a point where you can't use any more oxygen. You're never using it all, but you're going to get to a point where it just plateaus. And so endurance training helps improve VO2 max, and it does this several different ways. So probably the two main ways is that you're able to improve delivery, and that's the cardiovascular system. Remember, the cardiovascular system is a transportation system, and so we're able to get that oxygen where it needs to be, and we're able to do it more efficiently. And then once we get it to the muscle needs to be able to use it. And so we can increase the amount of oxygen that we're able to actually use. It's important to remember that even with training, VO2 generally doesn't change for a workload. Okay, there are some things that can actually happen, but all other things being equal, a trained individual versus someone that's exactly like him, or you take the same individual and you train them, their VO2 for a given intensity will cost the same amount regardless of their training state. Okay, and we see that from this figure here. So we've got people before training in blue, and then we've got after training in red. And you can see that as exercise intensity increases as measured by running speed, VO2 increases linearly until they plateau and reach VO2 max. Okay, so it increases, or training increases VO2. The oxygen requirement's the same, but what's happening, and this kind of ties into that first bullet point, is that for a given intensity, your heart rate's actually lower. And this is good because that means it gives your heart the ability to work harder, or has a greater distance, a greater reserve before it reaches max. And so as a result, ultimately, max heart rate occurs at a higher workload, which means you can work at a higher intensity. So here are the three things that I hope you can do. It's the same objectives as before. I just thought that was easy, so didn't reword them or anything, but can you do these three things?